Very good morning to all. I'm N. Satish Kumar, working as assistant professor in the Department of Artificial Intelligence and Machine Learning in R&D Engineering College. In this session, we're going to discuss about basic operational concept involved in computer organization and architectures. In this diagram, which describes about the interaction between the processors and memory, how instructions are handled by the processor as well as memory. So the first box, which contains as a processor, the entire units which contain as a processor, and this is belongs to memory. So in processor, we have several type of registers are performed in the processor. So various type of registers are PC, program counter, IR, instruction register, AR, memory address register, MTR, memory data register, and we have general purpose registers, as well as we have some functional units such as an ALU, and we have another unit is called as a control units. As well as this arrow indicates about the utilization of the addresses as well as data from the memories. As well as control units will handle all the units or coordinates all the units with help of the respective signals sending to it. It will discuss how the instruction is handled by the processor. At first, this program counter PC. So this is a basic operation we'll describe, which is listed one by one. That we'll discuss in diagram. PC. This is the program counter. The program counter which may use to handle the next instruction addresses from the memory. So PC is the first step that which holds the address of the next instructions. So this PC sends the signals to MAR, that means address instructions. So based on this MAR, memory address register, which handle the addresses from the main memories. So this MAR sends the signals to MDR, memory data registers, based in respective addresses, which type of data is stored in the particular register that will be handled by this MDR. This too performs memory registers. Then the data will be handled to the IR, that means instruction registers, which is used to ready for decode and execution states. This instruction register which is hold the data. Finally, this data will be transferred to the, or this data will be utilized by the ALU. ALU is arithmetic and logical units, which perform arithmetic operations as well as logical operation carried out in it. So example, add R1 comma R2. So here add is the add R1 comma R2. So add is the operation and R1 and R2 are the operands. R1 and R2 the operands. So R1 which indicates the registers. So in this, suppose R1 is one of the registers here, which is listed in general purpose registers. So here example is add R1 comma R2. In R1 we have one value, 10 is stored in the R1, as well as in R2, 20 is stored in the R2. So add is the operations. So ALU able to handle the arithmetic and logical operations. So this MAR, MDR perform the tasks such as getting the address as well as the content which is stored in the respective addresses. That will be process take plus this memory registers. So here in the respective registers, the content is stored here. So the content such as R1 is 10 and R2 is 20. that will be received from the respective register. Finally, based upon the operations add is here, that will be added and finally stored in the result R1 itself. Or we can store any other registers or any other memory addresses. This will be carried by the ALU operations. As well as this control unit coordinates all the registers as well as other memory units. So either the result will be right back to the memory or it can be moved to some output devices or some other memory locations. This is the process happened inside the processor. Thank you.